In this episode, I want to build an instrument with loops and fills and then a filter to control the sound of the loop. And it will work like this. If I press button number 1, I trigger a drum loop. If I press any of the other buttons, I will interrupt the loop with a fill-in. And then, finally, I can control the filter. Okay, so how is this done? Well, it's 2 steps. One is to construct the musical composition with loops and fill-ins so they synchronize together. And that is relating to the last episode. The last step in this episode will be about applying a filter to the musical content. Okay, but let's start with the musical structure. So in the music.xml file, we have one arrangement, which means that the files in the arrangement are all in sync. We have one track, and tracks are looping by default in this system. So it will loop itself with a loop length of 4 bars in the time signature of 4/4 in the tempo of 110 beats per minute. So if you want to replace my music with your music, you should make sure that you know the tempo, the time signature, and the length of your loop. Otherwise, it won't loop in time, so that's important. Just a side note, we can have any number of tracks playing in sync with each other, and they can all have different loop lengths, and they will just continue looping in sync with each other. But for the simplicity now, we just stay with one loop, and that's turned on with the button 1 because the arrangement has a class set to button 1, which means that it will be triggered when button 1 is pressed. Okie dokie, so this track plays the file with the name loop1.mp3 in the audio folder, exactly as we have done before. And a new thing here is that it is assigned to a voice. And you can think about a voice as a synthesizer monophonic voice. So we have just one kind of audio sound per voice coming through. You could also relate to a track in a DAW with one sample playing. Then if you have a new recording, that would replace the sound of the old one. So it won't like blend, but play. It will cut out the last one. So in this session, I have connected all the different objects here to the same voice, except for this one. That was wrong, actually. It should be drums, not drums 1. To be assigned to one voice. That means that if this one is playing, the looped track, and we trigger one of these, then the background loop will be quiet, so we don't hear it, but we will instead hear this object. Okay, so what is that? It's called motif, and the term is borrowed from film scoring, where we have musical elements played when something happens in the movie, and that should often be played in sync with the composition that is running in the background. It's sometimes called stinger. There might be other names for it, but I stick with motif. So you can see that they are connected to the different buttons. They are triggered. It's not toggling as we did with the tracks in the last episode, but we are triggering them. But now they are not triggered immediately, but they are quantized to a certain musical value, and that is defined here globally. It could be set differently or independently for each of these motifs, but now they are all using the global setting here of quantize being 1 quarter note. That means that when it receives the click, it waits for the next quarter note, and then it is starting the playback of the file. So you can see that we have 7 of those motifs, and they relate to the different files stored here in the audio folder, and they're all quantized to 1 quarter note. So we press the button, and on the next beat we will hear the sound. And then we need to talk about the voices as well. So they are all assigned to the voice called drums here, and they all have most of them have a length of 1 quarter note. And we have a few exceptions at the end here. So number 6 is 1 bar, for example, 4 notes, and 7 and 8 are 2 quarter notes. So this length, it determines for how long the background loop would be cut out. So this first one will cut out the sound of the background loop for 1 quarter note, replacing it with itself. But then after a quarter note, it will turn on the volume on the background loop again. But if we have some ringing cymbals or anything interesting, like an audio tail in this file, they will sound on top of the loop in the background. So it's used for making a lot of sense, where we have, for example, in number 6 here, a cymbal crash that is longer than 1 bar. But after a bar, the background music is coming back again, and the cymbal is ringing on top of that. Sorry, I can also see that I added here quantize 4/4. That means that this number 6, wait until the next bar line until it is triggered. So that is basically how we can synchronize looped audio files, that's track, and just single hits, that's motifs, but quantize the motifs with the background loop using the quantize settings, global or local, and then determine how it should replace the background loop by using the same voice name for all the objects that should replace each other. And motifs have a precedence over tracks, so they will cut out the sound of the track, and it will cut out for this amount of time that we specify with the length attribute. Okay, finally the filter. So you can see here that we have an output set to #music, and that makes the system search through the configuration in the audio.xml file for any object here with the ID of music. So we type output equals #music, and then we give an object the ID equals music. Just make sure you don't do the hashtag here, but just music. And this is according to the CSS selector rules in web technologies. Okay, so because it finds this gain node with the ID equals music, all the tracks, potential tracks, even if we just had one, and the motifs are connected to this gain node. So we can view this as an kind of an input on a mixing console, with an input with the ability of having many input cables going into the same channel. And then I said output equals next for this one, which means that the sound, which is now the sum of everything that is coming into it, is going into the filter. The filter is set to low pass, so we can do this effect, and the frequency of the low pass filter is set to variable f. I also made the Q value, the resonance of the filter, dynamic, and I set it to Q. For some reason I used a capital Q here, so I need to have capital Q up here. So we have two variables connected to two attributes on the filter. Okay, and the variables are reading device orientation gamma, which is this. Is it? Yes, this is gamma, rotation gamma. And it's mapping the values from -60, which is a bit to the left, and to +60, which is a bit to the right, and mapping it to useful values. So for this filter variable, the frequency variable, I map it to 50 Hertz up all the way to 10,000 Hertz. So it's quite close, almost just the bass notes heard, and it's almost open. So if we should make it extreme, we should go to 20,000 and down to 20 Hertz. That would make it all the way to our hearing range with frequencies. And then the Q value is mapped the same region for the degrees to 30 to 0. And 30, well, play around with the value. The higher, the more emphasized is the resonance. So it's get more cintier if it's a higher value there. And finally, it might be worth mentioning the curve attribute that makes the mapping non-linear between those values and those values. So it actually make an exponential curve when we map to frequencies, which is often very useful. So we save it and we can update the app and see if we can hear the change now on the filter. So I close the filter. And now it's completely closed. And completely opened. And we can try to make this Q value extreme as well. Very synthy. So that is interesting as well.